Hi students, welcome. So here again there is a question related to the photoelectric effect, radiation and the magnetic field. This is a JEE Main PYQ of 2014. In this question it is given that there is a radiation corresponding to 3 to 2 transition of hydrogen atom. It falls on the metal surface to produce the photoelectric effect. These photoelectrons are made to enter into a magnetic field of 3 multiplied by 10 to the power minus 4 Tesla. If the radius of the largest circular path followed by this electron is 10 mm, then the work function of the metal is close to. So if you look at this question carefully, so basically they are combining three concepts. First concept of the radiation. So like we have hydrogen atom. So for the hydrogen atom, as we know, the energy levels will be looking like this, that the lowest energy is minus 13.6 electron volt, then minus 3.4 electron volt, and then there is minus 1.5 electron volt, right? So we are taking a transition from 3 to 2, and in this transition there is a photon which is emitted. This photon we are taking for the photoelectric effect, right? Now this photon is falling on a metal surface. So let's suppose this is our metal surface. This metal surface, when this photon will fall on this metal surface, then there is a electron emission because of photoelectric effect. Now this electron is entering in some magnetic field. Let's suppose the magnetic field is like this, right? So then when any charged atom enters in a magnetic field, then it will start to rotate in a circular path, right? So here we know that the electrons are the charged subatomic particles, so they will start to rotate in the circular path. So here after entering, it is rotating in a circular manner like this, in a circular path, okay, kind of circular, okay, fine. So here they have given our radius of this circle, and it is rotating in a circle. The radius is given as 10 mm, right? And 3 to 2 transition of hydrogen atom. So this is our hydrogen atom. So first thing I am going to calculate is how much energy photon will be emitted from the 3 to 2 transition. That first thing I am going to calculate. So the energy is del E equals to E2 minus E1, right? So that will become minus 1.5 plus 3.4, okay, E2 minus E1, or this is basically our energy difference between the lower circular orbit and the higher orbit. So it becomes minus 1.5 plus 3.4, so it comes out to be 1.9 electron volt. It means the photon which is emitted is having an energy of 1.9 electron volt. Now when this photon falls on the surface, then if the energy of this photon is greater than the work function, then only electron will be emitted, or in this question we need not to think about that, because anyway electron is emitted, so work function should be less than this value, right? Now here this kinetic energy of this photon which is emitted is given in the terms of radius, right? So we can say kinetic energy is the energy of photon h phi, h mu minus phi. Phi is our work function. This is our equation of the Einstein's equation of photoelectric effect. We are going to apply this, right? So from here I can say that the kinetic energy is basically 1.9 minus phi. Now the problem is, if I know the kinetic energy, then I can find out, right? So let's call it as the equation 1. So for the kinetic energy, now I am going to apply this concept of the magnetic field and the charge. When the charge enters in any magnetic field, then the force on that is QVB, right? So force on that is QVB, provided V is perpendicular to B. So here V is anyway perpendicular to B, because the magnetic field is entering in this surface, whereas the electron is moving on this surface, right? So QVB will be balanced by centrifugal force mv square divided by r. So V and V cancelled out, so then we get that the mv is equals to qbr, right, or v equals to qbr divided by m. Okay, this is the velocity in the terms of radius, right? Or if you would have memorized this formula, r equals to mv divided by qb, so then you can directly apply that, right? Okay, so now we can find out the kinetic energy. So the kinetic energy of the particle would be half mv square, where m is the mass of this particle and here is electron, so that will be the mass of electron. So half m and v square becomes q square b square r square divided by m square. So if you wish, you can do the approximated calculation here. So kinetic energy will be q square is basically 1.6 multiplied by 10 to the power minus 19 square, because the charge on the electron is 1.6 multiplied by 10 to the power minus 19. So 1.6 multiplied by 10 to the power minus 19 multiplied by 1.6 multiplied by 10 to the power minus 19. Look, the magnetic field is given as 3 multiplied by 10 to the power minus 4. So 3 multiplied by 10 to the power minus 4, 3 multiplied by 10 to the power minus 4. Okay, and r is given as 10 mm, so that is 10 to the power 10 multiplied by 10 to the power minus 3, or 10 to the power minus 2 square becomes 10 to the power minus 4, right, divided by mass of the electron, that is 9.1 multiplied by 10 to the power minus 31. All right, so this is the value. Now problem with this kinetic energy is that this kinetic energy is in the joules. So if you divide the joule with the charge of electron, then we will get the kinetic energy in the electron volts. So let's divide it with the 1.6 multiplied by 10 to the power minus 19. So now here there is just mathematical calculation, so I am going to do that. Okay, after the calculation, the kinetic energy is 0.8 electron volt. Look, this is the maximum kinetic energy of the electron. Why maximum? Because we have been given the maximum radius. Corresponding to maximum radius, we will get the maximum velocity. Okay, corresponding to maximum velocity, we will get the maximum kinetic energy. That's why this kinetic energy is the maximum kinetic energy, which is 0.8 electron volt. Now we are going to apply the Einstein's equation of the photoelectric effect. This equation, equation 1, kinetic energy is equals to energy of photon minus the work function, right? So the kinetic energy is energy of photon, which is 1.9 minus phi, right? So from here phi comes out to be 1.9 minus kinetic energy, right? So phi is 1.9 and the kinetic energy is 0.8. Okay, so phi comes out to be 1.1 electron volt. This is our approximated calculation, because here we have done a bit approximation, right? So let's look at the options. So we have been given 1.8, 1.1 and 0.8 and 1.6. So look, option B will be correct. So first, whenever you do the approximation, you can look at the answer, so that you will get the answer. Either if like the answers are very close to each other, then we cannot do the approximation. But here, because the answers are very separate, 1.8, 1.1, 0.8 and 1.6, that's why you can do the approximations. So this thing you can apply, approximations you can apply, provided you look at the answers and they are very different from each other, right? Okay, thank you.